All right, I want to look at the graphing portion of this quiz. So the first part of the quiz, graphing part, this is number 7 from the quiz I gave to one of the two classes, maybe a little different version than you have, just depending on which version you had. Gives two equations. We've got negative 2x plus 5y is equal to 15. And we had a second equation, y is equal to 2x minus 5. So you'll notice the second equation is already in slope-intercept form. That's y equals mx plus b form. The first equation is not in slope-intercept form, and so we're going to need to go back and put that into slope-intercept form. Remember, you've got to isolate the y variable. And so in this equation over here, in this particular case, I can add 2x to both sides. And so we're going to end up getting 5y is equal to 2x plus 15. And then we'll divide everything by 5. And remember, when an equation gets divided by 5, you can't just divide part of the equation by 5. Everything has to get divided by 5. So that equation is going to end up being y equals, the slope there is going to be 2/5. Remember, 2x over 5 is the same thing as 2/5 x. 15 divided by 5 is 3. And those are our two equations. Okay. Now, graphing these should be relatively easy. Hopefully that's something you did a lot in Algebra 1. I don't have a real good setup for this, but to graph y equals 2x minus 5, you're going to go down 5 on the y-axis, 3, 4, 5. Your y-intercept is going to be right there. And then your slope is 2. Remember, a slope of 2 is 2 over 1. That's a rise of 2, and that's a run of 1. So you're going to go up 2 over 1. You're going to plot a point at, what would that be, 1, negative 3. And then you'll go up 2 over 1. You'll plot a point at 2, negative 1, and so on. And so your line is going to end up looking something kind of like this. For that other equation, it's 2/5 x plus 3. And so if you graph that line, you're going to start out at a y-intercept of 3. Your slope's going to be 2/5. So you're going to rise by 2, plot that original point there at a y-intercept of 3. You're going to rise by 2. You're going to run 3, and so on. I don't have graph paper, so in this particular example, it's going to be hard to actually show this in video. But the next part of the problem did ask you to find the intersection point. If you extend both of these two lines, which again, you won't be able to see on the video there, they actually will intersect at the point 5, 5. So that's where we're headed. And remember, if that point's on both graphs, you should be able to check and see, can you substitute the point 5, 5 back into both equations and have it work? If it does, then you know it works in both, and you know that's an intersection point of those two equations. Okay, so that's something that you want to keep in mind. Moving along to example number 9. We're given two different points. We want to find the equation of the line that passes through those points. And so we've got negative 1, 6, and we've got the point 2, 4. Okay. So you don't know what the y-intercept is. I suppose you could make a graph and you could try to, kind of continue the slope pattern, and you could figure out what the y-intercept is. But just in general, if you don't know what the y-intercept is, I would use point slope form to write your equation. And that's y minus y1 is equal to m times the quantity x minus x1. Okay. Remember that you want an x and a y variable in your final equation, so you're not filling those in the equation. X1 and y1, those are the coordinates of the actual point that your graph passes through. It can be any point the graph passes through, okay? And so we've got two different options here. Either one of those would be okay. Just for the heck of it, I'm going to use the point negative 1, 6. We've got an x-coordinate of negative 1, and we'll be filling that in for x1. We've got a y-coordinate of 6. We're going to be filling that in for the y1 value, and we just need to find the slope. Okay, so remember, slope is a rise over a run. Rise, of course, is in the y direction, so that's y2 minus y1. Run is in the x direction, that's x2 minus x1. And same kind of thing. We just need to substitute everything in and get that to work out. So the second y minus the first y, that's going to be 4 minus 6. The second x minus the first x, be careful, that's 2 minus negative 1. 4 minus 6, of course, is going to end up being negative 2. Be careful, minus a negative ends up being the equivalent of a plus. So that's a slope of negative 2/3, and that's what you're filling in to your equation. Okay, so your final equation here is going to end up being y minus 6 is equal to negative 2/3 times the quantity. And be careful, that's x minus a negative 1. Minus a negative, same thing as a plus. And so that's an x plus 1. Okay, now you could have used the other point. So you could have also gotten y minus 4 is equal to negative 2/3 times the quantity x minus 2. Those are the same thing. Okay, either one is fine. You can also put it in slope-intercept form, but you don't have to. Okay, moving along. So that's kind of your standard point slope form, and that should look real familiar from Algebra 1. Number 10 asks you to write the equation of a line passing through the point 2, negative 6, and perpendicular to 3x minus 5y is equal to 10. So once again, we don't know what the y-intercept is, so we're going to use point slope form. So I would probably write that down, and we've got to fill things in. They were nice. They already gave us the point that this is passing through. So my x1 is 2, my y1 is negative 6. We just have to find the slope, okay? Now, you go back up here. They were not nice that it's not in slope-intercept form. So we're going to have to put it in slope-intercept form. Subtract 3x from both sides. You get negative 5y is equal to negative 3x plus 10. Okay, we're going to divide both sides by negative 5. And anyway, if I did everything right there, it looks like the slope is going to be positive 3/5. Okay, so we have a slope of 3/5. But remember, we don't want a line parallel to it. We want a line that's perpendicular. So you take the opposite reciprocal. That's going to be negative 5/3. Okay, and so anyway, your final equation is going to be y minus negative 6 is equal to negative 5/3 times the quantity x minus 2. And again, if you simplify all that, minus a negative is a plus. So it's going to be y plus 6 equals negative 5/3 times the quantity x minus 2. So that's your final equation there. All right, so hopefully that was pretty quick and pretty easy for most people, mostly plug and chug. And then our final example, which is a perpendicular bisector equation. Okay, so they give us a triangle, and I'm going to make a quick graph. I'm not real worried about precision graphing here. I'm just using this as kind of a guide. We've got a point A at 1, 7. We've got a point B, negative 1, negative 3, which is down here. That's B, negative 1, negative 3. And we've got a point at 9, 1, which is C, which is somewhere over here. Okay, so C is 9, 1. And anyway, so we have a triangle, and it looks something kind of like that. They want the equation of the perpendicular bisector of side BC. Okay, so you can see side BC there. The perpendicular bisector would be perpendicular to it. It'll be bisecting it. It will not necessarily go through vertex A. So you need to be careful about that. They're asking us to write the equation of a line. So of course we're going to use point slope form. And we just need to kind of fill everything in here. Now, I need to know a point that it goes through. It may not go through the vertex. If that's not an isosceles triangle or an equilateral triangle, it won't go through the vertex. So it's dangerous to use the 1, 7. Not going to use that. I need this point right here. Okay, that point needs to bisect the base. So that point should be a midpoint. And remember, the midpoint between 2 points is the average of the x's and the average of the y's. Okay, so we'll do that. If we look at our x's here, the average of negative 1 and 9, negative 1 plus 9 is 8. 8 divided by 2 is 4. Okay, the average of the y's, we have negative 3 being added to 1. Negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. So that midpoint there is going to be the point 4 comma negative 1. Okay, that's our point right there. 4 comma negative 1. And okay, so that's our x and our y coordinate that our line passes through. Okay, so let's see, the x is 4. and the y is -1, okay? And now we just need to find the slope, okay? It's got to be perpendicular to BC, okay? If it's going to be perpendicular to BC, that means that it's going to need to go through the base at a perpendicular. We need the slope of the base, okay? And it's going to be perpendicular to that base slope. So we're looking for the slope of BC, okay? Slope is y2 minus y1. Sorry, I lost that point there. Point C is 9, 1. Okay, so y2 minus y1, that's going to be 1 minus -3. And that is going to be on the bottom, 9 minus -1. So that's going to be 4/10, which is 2/5. Okay, if this slope is 2/5, that means the slope of the perpendicular is the opposite reciprocal. It's -5/2. Okay, so that's our final slope there. We've got a -5/2 there, and we can fill that in. And so our final equation here, if we can put all this together, y minus -1 is y plus 1. And that's going to be equal to the slope of -5/2 times x minus x1. And that's our final equation. So a lot going on there. But if you just look at it at a step at a time, really you're looking for a point that it passes through. And, you think, oh, it's a perpendicular bisector. It's got to go through a midpoint. And, that's a pretty basic concept that probably you looked at in Algebra 1 and in geometry. And then number 2, you need the slope. And, it's got to be perpendicular to the base, which of course means it needs to be the opposite reciprocal slope of the base. And again, slope's a pretty basic idea. So if you start out with the equation, it really kind of guides you through the rest of the problem. But if you don't start with that equation and you just kind of jump into it blindly, you can end up having a lot of trouble. So hopefully that makes the last question on the quiz a little bit more straightforward, and hopefully those examples help with any of the problems on the quiz that you might have had trouble with.